Hi everyone, you can't talk about the domains of functions without talking about the range of functions. The range of functions is the set of all output values that the function reaches. So it's all possible y values, or all possible outputs. So from a table, a finite table like this one, meaning it only has a set number of entries, the range you can read off by just looking at the y values that you get. So for this example, we get 0, 4, 2, I only have to write 2 once, and -1. 3 is not in my range because there's no input that gives me an output of 3. So we can add that. Three is not in the range because no input gives 3 as an output. Okay, so from a graph, things might be a little bit trickier, but not too much. So if we look at the graph of a line, then given a y value, I look to see if there's an x value that has it as an output. So this x value down here has this y value as an output. So a way that I like to think about it is I just draw a horizontal line and see if from any given y value and see if that horizontal line hits my graph. If it does, then there's got to be an x value that got you there. So draw a horizontal line and see if it hits the graph. If it does, that y value is in the range. So for a line like this, I can get any y value I want. So the range of this one is all real numbers. We denote it with this symbol. In this graph, that's not necessarily true. I know that 2 is in the range because I can draw a horizontal line. I can get 2 by plugging in 3. All of these y values are in the range. Since my horizontal lines hit the graph, I could figure out which x value gives them to me. These 2. But as soon as I go bigger than 2, this horizontal line, no matter which direction I go, will never cross the graph. Also, no negative numbers are in the range because there's no output, or there's no input, no x value, which gives me an output that's negative. So the range here will just be 0 to 2. Those are the only values that I can reach. Now we'll move on to talking about range algebraically. So here is a function, g of x equals -x squared. The way that we find the range of a function like this is we ask ourselves, what do we know about this function? So what we know is that x squared is always bigger than 0. Then if I put a minus sign in front of that, so minus x squared is always going to be less than or equal to 0. So the range is going to be -infinity up to 0. Another way that you can think about this is, say I wanted to try to get -4. So can I get -4? Then my output would be -4, and I have to figure out which input gives it to me. And that works. I could plug in 2. Yes, x equals 2 means g of 2 equals -4. That's what we'd expect because we said that all the negative numbers are in our domain. We're not supposed to have any positive numbers, so what happens when I try to get a positive number? Let's try for 4. So which x is going to give me 4? Well, that would say that x squared is negative 4. So x is supposed to be the square root of negative 4, which we can't do. So this says 4 is not in the domain. I mean, not in the range, sorry. Which we had already realized because 4 is a positive number. We don't have any positive numbers in our domain. So let's look at this example for a moment. Negative x squared plus 7. So we know that this part of the function from our last example is less than or equal to 0. And then we add on 7. So the whole thing is just going to be less than or equal to 7. So the range will go from negative infinity up to 7 instead. So for example, 3, or now let's do 4. 4 is now in the range. Because if I try to figure out which x value gives me 4, I can actually solve it this time. I want to figure out which x is going to give me 4, so I'll subtract 7 from both sides of this. I get negative 3 equals negative x squared, which is the same as 3 equals x squared. So square root of 3 equals x. That says f of square root of 3 equals 4, so 4 is in the range. Okay, these next two examples are very similar because when we take the square root, we're always taking the positive square root. So no matter what I plug in for x, well, as long as I'm plugging in something from the domain, then when I take the square root of this, I'm going to get a positive number. So the range here is all the numbers from 0 up until infinity, all positive numbers. And I can use the range of the function square root of x minus 2, the same idea to find the range of the function square root of x, the whole thing minus 2. The square root of x is positive. So with this, I can get all possible positive numbers by plugging in different values for x. Then I'm going to subtract 2 off of it, and so it's the positive numbers minus 2. So my range will be negative 2 up to infinity instead. All right, I hope that these examples were helpful. We'll be using these properties in class over the next few days.